Hey, this is Mr. Ward, and we are going to be talking about the point slope form laser cannon battle commander, which is from level 5B, as in boy. And what you're going to be doing is Earth ships have gone out off the quadrants, and so using the old slope intercept form isn't as convenient. We need another equation form to use, and the equation form we're going to use is the point slope form equation. Now, the point slope form equation is this: y minus y1, where y1 is a y value of a point on the line, equals slope times x minus x1, where x1 is the x value from the same point that y1 came from. So there's a point on a line that is x1, y1, whatever it is. So you've got Earth ships and some Blargian ships, and I labeled them all. I know it's a little busy to look at, but I labeled them so it'd be easy for you to figure out what you're shooting from. So let's say you want to shoot this point at 2213 from this one at 23. So what we're going to do, and I find it useful to have this equation just right here, so I can just copy paste it. Let's say you're shooting from 2-3, and you're going to use 2-3 to shoot a bunch of stuff. And if you zoom out, you'll see some more ships out there. You got to get some more ships. You only need to shoot 5 on a slide. So you may find it useful to stick with one ship and then work out that you're using and work out the slopes. So if I'm using 2-3, x1 is 2 because that's going to be a part of a point that we need on the line. So we have x is 2 and y will be 3 because we're using 2-3. Then we just need to figure out what the slope is from 2-3 to 2213. So we can use the slope equation. So we go bump, bump. I'm making parentheses over parentheses. And I'm going to just put in my equation for the change of y. So from 3 to 13 would be 13 minus 3. So 13 minus 3. And then from that, now I find my x change down in the denominator. Remember, even though x comes first in the point and y comes second, we put the y change in the numerator and the x change in the denominator because we're always really caring about output change versus input change. All right, so I've got my change of y, 13 minus 3, and now I need to get my x change, 22 minus 2, and I need to go in the same direction to get the right sign. Though you can predict that this is going to be a line that goes up to the right, so the sign should be positive. So 22 minus 2. Okay, and that works. And then we can make it fancy. And it's very convenient that I've got this little subtraction here because this tells me the bookends of my x values, high end of 22 and a low end of 2. So I can just say 2 is less than or equal to x is less than or equal to 22. And I've made it fancy. And that shot that ship. Now I copy that. I paste that. I'm still using 2-3 as my main ship that I'm shooting from. And let's say I want to hit this one at 78.25 or this one at 88.3. I'll use the one at 88.3. No, I'm not going to do the one at 88.3. Blargians are immune to horizontal lines. That'll make a horizontal line. So let's hit the one at 78.25. So if I'm using 2-3, then I'm going to be changing this 22.13 to 78.25. So the numerator is going to deal with the y part, 25. And the denominator is going to deal with the x part, which was 78. Now, it's on its way, but it stopped because we didn't get our inequality to go all the way from 2 to 78. So our x values are going to need to go from 2 to 78, not 2 to 22. And there we go. You shot the ship. So just shoot 5 per slide. And the Blargian, you might have to zoom out a little bit here and there, but the Blargians come in from quadrant 2. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And here they're coming from quadrant 3. And in this one, I'm going to have to zoom out a little bit, but you'll see most of them they're all coming in from quadrant 4. Okay. So that's all there is to it. But you do want to use the point slope form. Avoid using other forms for this one because the point slope form is the point of this. I didn't even mean that pun. But the point slope form is the intention of this to do is to build your skill and confidence with the point slope form as a tool.